Okay, I start. There are still, there are only 16 students today. Less than half of the class is here. Okay, I guess half of the class still in Labor Day break mood. Okay, anyhow, I'm going to start the lecture today. So we're actually covering started the R programming part. Although the COVID has been useful, but there are some aspects of R language it doesn't cover very well. So I'm going to go over some of the basic programming features in R today. That's the R programming module. So there's a zip file. You can download that. Once you download it, you should see a folder like this. It's basically my folder right here. So you're going to have a PowerPoint slides I'm using now. And then there's a R Markdown file, which we'll go through. The base, maybe I should use R Markdown. That's actually more update. Please sign in. I see one more student join. So, for some reason, my R studio is very slow right now. Okay, good. It finally opened. Okay. So, how do I make this full screen? The learning objective for today, we learned how to use the loops, for loops and the while loops, and conditionals, distinguish the scope of variables in R. I learned how to write simple R functions and also save the working space. Okay, it's really quite a lot, but each one is actually quite simple. So, okay, the loop, the for loop has a syntax just like this. For you have to use smooth parentheses, by the way. For I in 1, 2, 3, and then we just print out I. So it's really not that complicated. Except in this case, I don't even use the curly bracket to specify the range of the loop operation. So the loop in this 1, 2, 3 is just 1, 2, 3. It just print out 1, 2, 3. So, and in addition to the for loop, R also has a while loop. That basically there is a condition. So in this case, we have to give I an initial condition, not to be 1. But if that's a condition, you have to make sure you are going to modify that condition inside the while loop. Otherwise, we will have a loop running forever. So this will be, if we use a flow chart, the while loop, you need to have something condition to check, is it done or not? Actually, that condition is implicitly implementing the for loop, but is taken behind. Basically, it's finished at the list or not. But the while loop, you have to do that explicitly. So, in fact, in this case, if I change the I equal I minus 1, the loop is also infinite loop. So because it's never going to be over 3, right? So it depends on the condition, but there are cases you may want infinite loop. They are indeed the case. although nothing is infinite in this world, but you could write principally an infinite loop in a programming language. So, okay, so that's basically a loop operation. If we go back to the RStudio, so there, we have first R loop. Oh, maybe I run that in the. Oh, someone put in a chat window. Could you that probably doesn't work in R, although we could try. I don't think I++ will work in RStudio. So for I in red, blue, and orange, so the for loops, we just print red, blue, and orange. 0.5, 1, 2, 5, print on I, and that's it. It's really, those are just simple for loops. So wait, these two, now I use a curly to specify the range. So here, inside of the range, everything is operated by the looping operation. So in this case, we just square it. Square it and then square root it. Hold on, does that make sense? I times I 0.5? No, that shouldn't be 0.5, that should be 0.25. Is it? Something is not right here. Oh, wait. I squared it and square rooted it is the same thing. Sorry. I'm even confused myself. sorry. I guess I was really bored. Write something even not myself looking at it, take a moment to recognize why it's same. So okay, well, it's a late afternoon, early evening. Sorry, my brain isn't as sharp as in the morning. Okay. Okay, so it is the same. That actually is correct. I times I, and then you square root, it will be I itself. Right? Actually, only when it's negative, then it will become positive, right? So
absolute value of I.
What?
The absolute value of I.
Right, yeah. Very good, yeah. Thank you. Yeah, it's basically almost like take an absolute operation of the I function, I variable. Sorry. Okay, this is correct. Sorry. This one, well, this is really not much. It's just still print the answer. The while loop, this is +2 minus 10, 2, 4. That seems to be correct. Yeah. So those are just for loop and while loop. So actually, I think I may have some Socratic question. I forgot. Okay. So, I'm going to jump over this. So, okay. So just to see whether you are paying attention or not. Now, let's please describe how to loop over 1, 5 to 10, 15 in R. Someone is really quick. I'm going to wait so a few more students can put their input there. Okay, one more student, I will go over the answers. Okay, good. So let's see. Oh, very good. So Well, yeah, almost all correct answers. Yeah, very good. Yeah, yeah. Oh, very good. It looks like everybody, except this one, you need to put the scoping or do something there. But principally, that's also correct. It's just a few things like that. Okay, very good. Everybody is paying attention. This is good. All right. So now let's move on to the next one, the conditional. The conditional will be like is true and false. I guess there is no neutral or the option can be the same. So if yeah, the computer science x less than 1, it will be either true and false. There's nothing in between, I guess. Yeah. So I guess computer science is not inclusive in a sense. So it just compare true and false, black and white. So let's see. X less than 1, is that correct? That should be false because x equal 1, 1 equal 1. So that should be false. If it's false, that's an AND operation. That means this is false. Then we should print out the x is not between 0 and 1. Is that correct? Okay. I'm talking myself out. Hopefully, no, let's see. Oh, very good. So it looked like okay. My brain isn't as slow as I thought it was. So that's still correct. So okay. How about the x? You already see the answer, right? X equal 0.5. Let's see whether this makes sense. X equal 0.5. That means is false. Negative or false. Exclamation sign means negate. Negative false, that means true. So this is true. 0.5 less than 0, that's a false. This is true. So true and true is also true. So we print out the x is between 0 and 1. Oh, okay, that's correct. So this is just for some exercise, I guess. I mean, we can change this to something else, see whether it's wrong or not, right? So if I change that to, whoops, sorry. If I remove one of the negate sign, be false and false, we shouldn't print out that, right? So that should be print out something else. Actually, this is not a good way to, it's just print out nothing because maybe the next one will be more, because then we also have to use else. Okay, I guess I'm jumping a little ahead of myself. That's actually, if we modify the next one, maybe because then there is an else. So if that's just if we put the else, then let's just add the else print. Oh, and then the logical won't be same though. Let's just say something else. Okay, it does print something else. Okay. So although I need to change it back, otherwise the logic is not correct. Okay, yeah, I'll change it back. So, then we can change this to 1.5. How about that? Okay, then it's print out something else. So, okay. This will be just additional exercise. You can't go away on your own. So, we can also use if-else function. This is the R built-in function, if-else. So X is that, and we apply a function is NA missing data or not. If it's missing data, we just take the median of that value and put it there. Okay, hold on. If it's correct, otherwise it's the X itself. Okay, so you can actually look at the help menu. Else, the help menu will be if else. You have a logical test. If it's true, you give the value. If it's no, you give another value. So in this case, what I'm trying to say is, sorry, my touchpad is oversensitive. In this case, what I'm saying is, if it's a missing number, I'm going to use a median to replace that number. Otherwise, I leave it the same. This is actually very useful to deal with missing data, by the way. So how to deal with missing data? This is one approach. If you don't like median, you can use a mean. Right. So how to replace that missing number? That may not, using the population may not be the good approach for the missing data. You could take a neighbor, for example, like the COVID data set. You don't like Saturday, Sunday have 0. You may want to spread out Monday, Tuesday to 4 days. Right? Maybe that's more appropriate way. It depends, right? So, and in fact, if you look at Florida's reporting, Florida now, every week they just had 1 number, and all other 6 days are all 0. So for Florida, there you have to divide that weekly by 7 to get a daily average. Okay, and that's just sorry. It's this is a if else you can use it to deal with missing numbers. So okay. In fact, if we go back to, oops, that's not. Oh, it's in the window inside my R window. So additional. Yeah. So in this case, I guess the median must be 3 then. Yeah, it does look like median is 3, right? 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 3, the one in the middle. So okay, that's correct. So, okay, so the next part actually is more challenging part. We need to understand the function and the scope of a variable. This is probably, and for those in computer science, this is not a big deal because you have learned Java and Python in lower level courses. Those from biology, this is probably one of the most important concepts you need to understand. So function and the scope of variable is one of the most important concepts in computer science or programming language. This is because, let's say we use X to represent a number. There are only so many letters we can use. So if you use X, your friend also use X, your boss uses X, your collaborator uses X, they may mean different things, right? So if, in fact, in older days, when people don't realize this is a problem, and then when people collaborate on something, they merge their code, they found that nothing works. One of the reasons is because many of the variables, they mean different things. Oh, hold on, there's something in the chat window. Oh, I see. I guess people are discussing what the. Oh, that's good. Sorry. People joining later is asking questions. Very good. Yeah. So. Okay. So. Yeah, NA dot remove true means remove the missing number. Very good. It looks like this chat window is useful in a way. So students can help each other. Well, even though I'm busy with my own screen. So very good. Yeah. Thank you for all those who answered the question in the chat. So, okay. So now let's look at this example. This is just a simple function to mimic something so-called a random walk. Basically, if you random walk, basically, let's say you want to go home, you probably have a direction where you want to go. But what if you forgot where your home is and you just close your eye, try to walk home? That would be a random walk. So, maybe it's a bad joke. Random walk, basically, you close your eye, just walk randomly in the parking lot. So in this case, what I'm trying to mimicking walk randomly for 100 steps. And how do I do that? I generate a random variable, a random variable based on the Gaussian distribution. That's one variable. I have what? 100 steps. I start with 0. And then I just plotted the random. Once I finish the random walk, I plot it out. Oh, by the way, this function actually takes no input variable because I put the variable outside. This is what it means global variable. I put this global with respect to this function though. So if I run this, there, I start from 0. Even though it's random, I mean, it looks like it randomly goes to the right, and then it's coming back a little bit. I guess if we put it even longer, 500, maybe it looks more random. Right now it doesn't look random. Okay, now it's it's still doesn't look like a random. It's still going to one direction, and that's interesting. Even though, I mean, I try to 1000. Okay, this now looks random. Still doesn't look random, does it? The random walk. This is actually a random process. So if this actually is intent. You can detect what is the actual random, what is the, so this, even though when we doesn't look at random, it's actually generated by random process. When we actually, human eye, look at something, say this is really random, that may not be random. This is what, so the human eye actually not a very good the detector for mathematical correct things. Yeah. So even though this is generated randomly, but we look at it, say this doesn't look like random. So, and human eye may or may not give you correct judgment. That's basically, unfortunately. So, oh my goodness, this really doesn't look like random, isn't?
If you run it multiple times, the outcome's always different.
Yeah. I generate 1 million. That's actually take a while. I probably shouldn't do that. But this is actually a random walk. So for every step, the next step. Okay, actually this looks more or less like random now. You could say this, if you actually model this the stock market, this actually doesn't look like a stock market. You have good year and downturn, good year. Sorry. That's actually a whole different topic. How to study the time series. So, okay, I'm going to change this back to 100. Okay. Well, this is actually not more. Well. So actually, if you want to fix the random seeds, you can then have it repeatable. So, but right now, this every time it changes because I didn't fix the random seed. It also, look at, I have no input parameter. So basically, I put everything outside as a global parameter. So, notice this return x. It basically return my simulated a random walk outside of the random function I generate. So that's actually the syntax of the R function. I think it's also on my slides. So we went over conditional. This is actually a review of conditional: equal, not equal, greater than, less than. Oops, ampersand. A vertical line means all, exclamation means not. Yeah. So those are basic syntax. Basic function definition is you have the function name equal function with a parameter inside. In this particular function, actually, I didn't even ask them for a parameter. It's nothing, because the parameter I'm using is actually the global one. That actually means inside the function, you can access the global variable, but outside of this function, you cannot access anything inside of that function as the local variable. I think the next few examples we're going to see that. So, okay, so now we are talking about scoping of the variables. So here, x 1, 2, 3, 4, 7, 9. That's the global variable. Y I also designed as the global variable. And then I write a function, take even, basically pick the even number of the input list. X is a vector, it's just a list of numbers. And then inside this function, I declare Y as another variable. This is a local copy inside of the loop. So this inside of this, I have another Y. What I do then, I go over every number of the X from the first one to the last one, length, that's the last one. If the X mode 2 is 0, then it's the even number. So 2 mode 2 is 0, 4 mode 2 is 0, 3 mode 2 is 1. So yeah. And if it's an even number, I put the X into Y. This is a local Y. And this is actually almost like added to the end of it. And to make it clear which Y we are using, I'm going to print inside the Y and then print Y and of inside to make it very clear what's inside, what's outside. And then we are going to run this function on the X. See, the output should be, let's see, 2 and 4. Only 2 and 4 are the even number in this. So on this. So inside the Y, you have 2, 4, and now that's 2 and 4. But outside, that Y is always say I am global. So after run this, I paste it, I print out the Y. That Y is still says I am global. So does this make sense? So I have 2 Y value here. 2 Y variable, the outside Y is the global. Inside of the Y, going to return the even number. You can actually inside the Y 4, 10, 100, 0. So those are just even numbers, I guess. Yeah. So, but outside that Y is always I am global, even though this 2Y, but really they are mean different things. So if I print that out again, yeah, so there. Outside that Y is always say I am global. So there, that's the, so even though we have 2 variable Y, they actually represent different objects. It's almost like 2 people with the same name. Like there's a John, there's another John, but are they the same person? No, one John maybe is the police. The other gem maybe is the, I don't know, the bad guy. So, right, they could be that even though they both have the same name, they are different individuals. So in this case, we have two variables, both named y. They are not the same object inside of computer. So study this code, you actually will understand what the scoping means. But that said, in general, you really don't want to do this to yourself. You just call the outside y outside. Inside, you just use something else. You say y inside. You don't use exactly the same name everywhere. It's just to keep yourself give yourself some break, right? So the good programming practice just avoid using the same name everywhere. So that will be the good practice, yeah. Then you don't have to deal with these kind of subtle things. And that actually, especially the case when you have a bug, and then you start to question whether you made a mistake somewhere in the code, right? So, and then if you call it X everywhere, you can't even debug it. It'll be very hard to debug that. So, yeah. So the good programming practice is use a clear, informative name for your variable. So, even though in principle you could use scoping to deal with these things, but really that's a bad practice. So, okay. So we can actually also write a function to call another function. So the previous function, I say take the even number, and then the next function I'm going to even number, going to call that previous function and calculate the sum of it. So this is a function called another function. And you can use that to build more complicated functions. So in this case, actually that, we take the even total, what should that be? 2, 4, minus, that should be 0, is it? Let's run this. Yeah, actually that's it, 0, yeah. So 0 minus 2 minus 4, they are all even numbers. So if we sum them up, that actually is a 0. Okay, here's another exercise on the scope of the variables. So with x global variable, y is also a global variable, y outside equal y, inside, oh, this is very confusing again. Let's see. Y again, then I create a y as a local copy. I take the mean of the x. Anything greater than the x I put into y. That's the so-called take upper half of the list. And then I put that as a y inside. Y inside I print it out. And then I return y outside. By default, if you put the last line, even if you don't say return y, it's still going to return y. That's just how our syntax works. It's actually not a good practice. If I were the one developer R language, I wouldn't allow this syntax, but that's just how R works. Right now, you can just put y as the last line and actually return. Okay. And then we take the upper half of the input x and look at the mean and check. And at the same time, we check the outside. It should remain the same. Okay, let's look at the output already. Okay, output. I should already generate that. Okay, so scopes. All right. So let's see. The mean is 2.5, so 3 and 4 are taken. Very good. So yeah. Let's see. Mean 2.5. Inside. Yeah, very good. Inside is 3 and 4 are taken. So this is correct. So inside we have 3 and 4. Outside -1, -4, -3, -4. Okay, that's still there. Yeah, so there. This time, even though I gave it a y everywhere, but I intentionally also made it different. Y dot outside or y dot inside to make it, I guess, give us a break on our sanity. So, yeah. Okay, so in principle, you should just use y dot outside, y dot inside, and don't even have to worry about the same name anymore. So, but that said, I would say maybe in some job interview, this kind of question will come up. Besides, scoping is a very important concept in any programming language. Okay, but how do we return more than one function? You can return it as a list. Well, that actually is still return one result, but you put it aggregate as a different. So you actually still return one list, but you can unpack that list outside. So in this case, we have multiple return. We just return two lists. I'm going to return one list, which is the integer, another list of the string. So yeah, so there. So first list is what? We return that as the list. The first list, the list actually using double bracket as the indexing. The first element of that list is what? Is actually is integer. The second one of that list is character. So there you see the how to return multiple objects. If you compare this with Python, this is a very awkward way. Or any other language. So there, R is it works, but it doesn't look pretty. So yeah. Anyhow, but this is how R deal with multiple object return. So yeah. Yeah. R, for those who want to understand what R norm is, you can look at the help function. R is just a random number, norm in normal distribution. So, yeah. Okay. Well, actually, we have been using package a lot. So but this is the R have in fact, R have last time I checked 30,000 some package now. So yeah, so this is really a lot. And one of the reasons why R is so popular is also because of so many people have using R to generate a lot of code already there. So although there's also an issue there, there are so many people writing code, not many people to do quality check. It's just a lot of people just busy generating a lot of code. So you need to do quality check yourself or run testing, make sure it is working. That said, based on the agile principle, it seems like you're shifting a lot of testing to the customer. You basically deliver it, a customer doesn't like it, you change it. Customer reporting an error, you say, oh, you change it, then you fix it. Apparently, that's what the agile principle is. So You basically deliver something is functional, but you put it all in the fine detail cell. We are not responsible for any mistake or disaster. If you actually read the fine detail in almost every software, you'll see that. Yeah. So use it as it is. They don't take any responsibility. In fact, when you download the R or RStudio, read the fine detail, it has similar language like this. Yeah, so, which is the kind of really odd. If you buy a car, you say the car, we don't guarantee this car will work. That seems to be really odd. But you buy a software, that's actually what in the language. So, yeah. Okay, sorry, a bit off the topic. Okay, so let's see. We have today is actually a bit light compared to the COVID data set. Those are all very simple simulated data set. For loop, while loop, conditional, scoping of the variable, how to write a simple R function. Oh, the last one, save the working space. Okay, that's actually really straightforward. Just save it as the image. And this is actually useful when you have a very large project. You are worried after running for a long time, you are worried about how to, maybe there's a power outage or how to reproduce. You can save every environment in a binary format. It is useful sometimes, especially when you are working on a very large project. And once you save it, you can load that binary image back. Yeah. So apparently, so if I save that, notice on the up right corner, those are the environmental variables. So if I save that image and then remove, everything will be gone, right? So if I just run these few lines, there, nothing. See, environment is empty, nothing is there. Right? But if I load this image back, oh, everything is back. See, W, X, Y, Z. I don't even remember where that W is, but apparently I use it somewhere. So yeah. So those are the variable we just use, and those are the function we just use. Even total, or there's actually a few other things that we haven't go through it. So, yeah. Random walk, that's the random walk function I use it, the first example function. So there, that's the, yeah. So actually, I want to show you another example of the function I use is something called make solutions. Yeah, there's another example called make solution.r or .rmd. Sorry. So this is the example. I want to show you how to gradually build a more complicated function. For those who need a refresh on what the making solution is, this is actually a very common practice when you are taking the like the science requirement, when you are working in a chemical lab or chemistry lab, you need to change the different solutions. So something called millimolar. So you need to know the formula weight. And then based on the formula weight, you estimate how much weight you need to make that molar solution. In fact, the molar formula, maybe if you Google Wikipedia, you will see that. For those in the computer science or data science, let me see. Molar solution formula, molar solution formula. Oh yeah, that right there. So molar concentration, number of solute divided by the volume. although I think Wikipedia have a better yeah, molar concentration, molar solution. You can actually read that. So I believe this is in middle school or high school. And my daughter actually has a homework assignment, something like that. Yeah. Although this Wikipedia page is overcomplicated. Here, that example, they also use sodium chloride example. So hold on. Yeah, so here, sodium chloride dissolved in mass. So this is also a bit overcome. All we need is here. So 116 divided by the concentration molar per liter is a molar mass. Okay, so our question is, say, if we want to make let's see, the molar formula for sodium chloride 58.443 for 1 liter of 1 molar solution. How much sodium chloride do we need? 1 millimolar is 1 out of 1,000 per molar, and 1 milliliter is 1 out of 1,000 and 1 liter. By the way, 1 gallon milk is about 3.5 liters something. So you get an understanding of the unit definition. So we're going to say X and Y will be the input volume, X millimeter, Y molar solution. So, and then the formula weight of the sodium chloride 58.433. And so basically we convert those first into molar, convert the volume into liter, and then just time the formula. So there, that means for 100 millimolar solution, 500 milliliter sodium chloride of sodium chloride, we need 2.92 grams of sodium chloride. This works, but look how odd this is. It only works for sodium chloride. So not a very useful computational solution. There's no general usability. It's not basically you cannot sell this to many users, right? It's not very useful. You need to think about how to generalize this, right? So make it more useful. Well, the next one, maybe we put formula weight as a parameter, right? So the first one, we just say the concentration of volume is not much. The next version, we're going to put formula weight. And then we still put the concentration of volume normalized by the, divided by 1 milli. Actually, that's because the first time we divided by 1,000 twice. So it's basically divided by 1 milli. And for the second version, that means we can apply to any chemical as long as we know the formula weight. Right, so there. So this time we're going to, if we calculate for 100 millimolar and 500 milliliter sodium chloride solution, we need 2.922 grams of sodium chloride. But if we need to do it for potassium chloride, that formula weight is 74.55. And then you can just put it there. So there, this is our second version of function. So it's more useful as long as we know the formula weight. The third version, this time we don't even have to put the formula weight, we can just put the formula or the name of the chemical there. That will be more useful. And otherwise, you're going to ask a user to remember the formula weight all the time, right? So this time, well, for this version, I don't have a database or whatever. I just manually put a list of 4 chemicals. So this is just for 4 chemicals. so there. Well, what I put is just 4 chemicals: sodium chloride, potassium chloride, sodium nitrate, and sodium hydroxide. There, 4 chemicals, and their formula weight is there. And then, how do we get that for every input? Since we know the formula, and we can just use that formula as an index to look for the formula weight. Let's basically take advantage of R's indexing function, right? So this is actually a general way, something called lookup table, using indexing to look up a value. This is a very common way in computational or software. So right now I'm looking for a formula weight. You could look it for example, if it's the telephone book, you have the username, address. Well, you have the username, and you put people's name. If that username is a telephone address book, they will match that to a few records. Those records will match to some positions in the database. If it's a list, and you just indexing it. And actually, if it's a database, you need to know the primary key, how to find it. Yeah. Okay, in my case, I don't have a database. I just have a list. It's a vector in R, and those positions are indexed by the formula, chemical formula. So there, I just use a formula to index that list, that vector, and then I have the formula weight. And then once we have the formula weight, we can just use the same formula, return the result. So this is version 3. Right, so the first one is for sodium chloride, 100 millimole, 502.92. Well, I've been doing that for 3 times by now, so that's correct. So the second one is sodium hydroxide, 100.1.5, that's 40, 540, that's 2, that's correct. Yeah, so good. So this is my example to show you how to using R build a more complicated function. It's also like build on the better version. It's become more useful, I guess. I mean, in theory, you could write even a larger, better version of. If you have a database, search for the chemical, like a Sigma database, search for the chemical and return. Although you probably really don't need. If you really have a chemical database, you can do things much more useful than just do this kind of calculation. So, okay. In fact, if you really have a chemical database, cover all the available compounds, one of the useful things you can do is to dock every known chemical compound into some tumor genes and see whether they can stop cancer, those kind of things. So, yeah, that's actually probably more useful. So, yeah. So, okay. So, let me see. I hope I covered everything I want to cover. Lies and accelerated tech. Yeah, so those are the important part. Let me make sure. Let's review what I covered today. How to do a for loop, how to do a while loop, how to use conditionals, how to distinguish the scope of a variables, write simple R function, and save working space. Yeah, so. Wow, I finished it in 50 minutes. But those are actually all very important concepts and skills. Yeah. So, in fact, for loop, while loop functions. It's not just important for R, it's important for almost all programming language. Yeah, I can't even think of programming language that doesn't have for loop or while loop. It'll be a shock to me if it's some program language that can operate without those things. Yeah, so. Okay. There's another very important thing I want to announce. That is about the midterm project. So I released them already. Okay, midterm project. There are two projects. The first one is called Global COVID-19 Case Analysis. All the exams are independent exams, but you can use any relevant material you can find, except asking for help from another human being. So if an independent exam, you can do it anywhere you like. You need to submit your RMD file and the HTML output with running result. And you should screencast your coding process sufficiently to demonstrate your effort. And this is a large project. You may work on multiple days. So as long as you record a sufficient video, upload them, that's good enough. Yeah, so.
Is that?
Say it again. There's a question I heard. Yeah. Hello. Oh, what do I mean? That's basically the HTML output. Yeah. That's basically this kind of output. So you need to have a running result and the output. Yeah. Very good using net. Yeah. So very good. So you should submit all your video in a hyperlinked URL in Word. Your Word has to be uploaded directly into UTC Learn. If you zip your Word inside of zip file, it means that means you have somehow blocked the access of the Word file. So, the global COVID-19 data set is basically a different CSV file. We have been always analyze this one, but there's another, the US one, but there's also a global one. Right? So that's the data you have to analyze. I do not need a separate documentation. Yeah. You just have to put it inside of your RMD file. There's no report. This is not a final project. This is just midterm to see what it is. Yeah. Now you look at the rubric. What do you need? A screencast video. You need to analyze daily case of first country, and then you also need to analyze the Google mobility for that country, and then merge the daily cases and Google mobility for that country. This is for undergrad. Undergrad only need to analyze one country. For graduate students, for graduate student, not graduates, I guess. Sorry, let me check that. For graduate student, you need to analyze 2 countries. So okay, so basically the undergrad you need to do 1 country, graduate student need to do 2 countries.
Extra credit for the undergrad student?
Sure. I mean, if you although it's actually you don't. I mean, depend on what they do. Yeah. So, but you are not required to do. If you do 2, yeah, I can give. If it's good, I'll give you some extra credit. So, yeah. Okay, but you are not required to do that. Oops, how do I get to the second project?
Dr. Chin, I have a question about assignment for the graduates. So we do it for 2 countries. Are we supposed to compare them or just plot the graphs for the 2 countries?
Look at the rubric. It did not ask you to compare them, but if
Okay.
you do that, it's okay. But the rubric didn't ask you to compare them.
Okay, thank you.
Look at the rubric. That's how you'll be graded. This one also has a rubric. So the second country, second project, we actually provided the data to you. Yeah. So this one is about the COVID variant tracking. So this is again the independent exam. I provided the data to you. It's actually in a zip file. But the information of that zip file is here. It basically describes the variants of the COVID. It's actually something called clade and the lineage. And the clade is something called SLV, GK, GH, GR, GV, GRY. I think GK, that's what the delta is. This is what the delta variant is. It really doesn't matter because I'm not asking you to do the delta. Basically, you need to, for undergrad, with that given data, you need to generate a figure like this. Figure 1, undergrad. For graduate student, you are expected to generate figure 1 and figure 2 like this. So that's the second part of it. In fact, there is even a previous student, that's an undergrad tutorial. You can actually watch his video how to do that. In fact, he also explained what those variants are. So it's a good tutorial. Yeah. That's actually the undergrad work with me in the summer. So, and in fact, he even have a RPub to explain this. So there, Landon Curl, he actually generated those figures. Continental plot, country plot. And he even have even more, but you are not required to do that. Okay, so that's the second project. Question about, I see something in the chat window. Those companies supposed to be an overlay set. The Midterm exam did not ask you to overlay them. You could, if you wish. Do you need to do both? Yes, you do. That's the 2 projects of Midterm. So that's the 2 Midterm projects. And they are both due on October 4th. So, and today is September 8th. So how many days do you have to October 4th? How would you find out? Actually, let me just open a Socratic question. How would you use R to find that one out? Oh, this is also a fun question. Are you ready for midterm project? Well, it's almost, this is the, not sure seems to be a majority. Well, you need to go over the US COVID-19 data analysis, and then you also need to finish the data cam ggplot the module to learn how to do ggplot plot. Once if you, there's nothing new in the project one. These are just apply the US COVID data method to the global data. For the project two, you just have to know how to do ggplot and average the aggregate the data set. So. Okay, the question is how many days from today to the due of the midterm project? Let me write the question. A question in the chat window. Question: how many days do we have until midterm project are due on October 4th? You could write maybe one line of R code to get it done. In fact, I think we did this many times in the time window analysis. Today is September 8th. So. Yeah, you can work on the code and yeah, you can work on the code. Yeah. I need to see the live coding, at least a substantial of it. Yeah. Basically, if you already have the code, you just talk it over, that's 0 point. I need to see the effort to show people are writing on their project. So basically, there's no, I want to minimize the probability of anyone copy paste another student's code. So. Yeah, it can be a very long video. As long as you register a YouTube video, you can upload for hours. So. You can also upload multiple videos. That's probably the case. Yeah, because you may work on multiple days, right? So. And you don't.
What's the question?
Oh, the question is there. There, question is. Oh, sorry. I need to. This is a free answer, not a multiple choice. My bad. Sorry. Here, put your answer there. Sorry, I picked the wrong type. They put how many days are there? How do we find out what's the result? So. Yeah, very good. That's one way to find it out. Yeah. Let me type bro. Something is not right.
There's a
26 days. Very good there. You have 26 days to finish this project. So enough time. So. Although there are other ways to do that. So if you do it Luber date, I often use Luber date, which is more so. Yeah, it should be in the same. Okay, so it's a good practice for you to do something minor, but still refresh your skill set, I guess. Of the yeah. So okay. So other questions? We still have a few minutes left.
Hey, Dr. Chin.
Yes.
Quick question. Just this may be a stupid question. The when you say overlay, do you mean like literally just plotting these things? Like, is that what you mean by overlay? These
GG
variables?
plot, overlay plot. Hold
Yes.
on. Oh, you mean a question? Hold on. Let me see. Maybe
You were very clear. I just want to be sure that when you say you're to overlay, that I understand that using we're overlaying using ggplot.
you don't have to use ggplot. Let me. You expect to overlay the country. You are expect to generate a figure. How about that? Generate.
Okay, that helps me understand. Thank you.
Plot. Okay. And then you have to overlay. Is it? You expect to generate a figure that overlays the COVID-19 data case at in a country. Okay, in a country, that's fine. In a country with the average Google mobility data available. Yeah.
Thank
like
you.
a numeric figure?
Say it again.
Like what kind of figure?
You can decide. I mean, a figure overlay COVID-19 daily case with a Google mobility. What kind of figure you can? I think you should make a judgment on that. So, yeah. Basically, this is also a data visualization question. So maybe you can come up with much better figures. So there's actually a hidden issue. I didn't. You are once you start working on it, you will realize the Google mobility data, you need to average for every country. So you need to use the group by and average, summarize across. So it's, even though I just say generate that figure, but it's actually not that straightforward. You need to figure out how to average it out. So there. Even though look like a very straightforward question, but you need to average the Google mobility out. So actually, I did give you here. You are recommend to average the regional mobility in that country in order to overlay this. So you need to, because each country mobility result is give it by state. Like in the US, you have 58 states apparently, including 2 cruise ships. So yeah, but in other countries like India, you also have a lot of provinces, I guess, in India. Yeah. So you need to average the result just if you want to overlay with the entire India result. So I mean, you basically have to do in I guess it doesn't have to be Italy, UK, or India. It could be. We can cut. What other country you want to do? Now the trouble is you have to do it in a country where Google actually is allowed to operate. Like in China, they don't they don't give you Google mobility report. So I think Italy, UK, and India, you will find in a Google mobility report. Yeah. So if someone want to work in another country and there's the data, you let me know. I will add it into that list. So yeah. Okay. So this is for project 1. I hope you will have fun with this because that seems to be. I found it. To be honest, I did many of the project myself, try to see whether it can be done or not. So I did it overnight. So for the project 2, I even gave you some sample plot. I hope the Zoom, not the Zoom Canvas gave me a good feature just jumping out between the assignment. Apparently, I don't know. I have to just going back to pick. Yeah, see, I have to go back to the entire module and pick another one. I hope the interface can have a more quicker way for me. Okay, so for this one, I can give you an example. You just need to generate that 2 figures. So And how you are going to do it, I don't really care. As long as you can generate a figure. I'm sure there are many different ways to do this. Yeah. So, and there's also a sample student video to explain to you some background. So, yeah. I hope you have fun with this. So, or at least find it interesting to do. Yeah. And besides, it's a real data. Yeah. So, and it's also quite relevant. So. Okay. I ended right on time. Yeah. And any more questions? Oh, hold on. For those who haven't signed in, for those who haven't signed in, oh, I forgot to go over some review questions. That's fine. For those who haven't signed in, you can sign in now. Otherwise, I'll see you. Oh, I'll see you next week. Okay, bye.
Thank you.
Bye.